Now, I want to save us some time here, and then because we want to develop the formula. So as we look at this, we're still going from 1 to 4. I went to 25 rectangles. That's what it looks like. It did an estimate of the area. It's bigger than our 17. So for 25, we're 18.18. They say the actual is actually 18.667. So we're getting closer. Then I did the same thing, only this time I used 50 rectangles. It gave me an estimated area of 18.42. There's the actual area. So I got a better estimate this time. Got a little more, a little less error. Then I went to 100 rectangles. Notice how what's happening is these guys are getting tighter and tighter. Eventually, so this is, notice I'm getting better, and that's the actual area. Now, essentially, what we're going to do, since this is a calculus problem, is we're going to let the number of rectangles become infinite. So we want the number of rectangles, which we're going to call n, to go to infinity. That will make this almost look like a solid block to get the actual area. So here's how it works. An estimated area, which is what we've been doing, is the sum from k equal 1 to n. This is your height of the rectangle. This is your bottom or width. So it's the sum from k equal 1 to n of essentially f of whatever that value was times delta x, which is the width. The last time we worked it, it was 1/2. Now in calculus, what we're going to do is we're going to take the limit as this goes to infinity. As the number of rectangles become infinite, so it's going to be more than 100 rectangles. What it's defined to be is what we just did, was the definite integral from a to b of f of x dx. That is the actual area. That's the actual area. So if I were to take a look at this and say, okay, they told me the actual area is 18 3/4 or 18.667. I'm looking at x squared. I take the integral from 2 to 4 of x squared dx. We know that's x cubed over 3. We evaluate it from 2 to 4. This is going to be 4 cubed divided by 3 minus 2 cubed divided by 3. Now, if I were to put it into my calculator, 4 cubed divided by 3 minus 2 cubed divided by 3. Look at that. 18 and a bunch of 6s. Which is what they said the actual area was. It's just the definite integral, what we just did.